Hi everybody, welcome to another amazing Max tutorial. As you probably already know, my tutorials are focused on the jitter side of Max, so on the visual side. In this particular tutorial, I would like to recreate with you some visuals that I saw on a YouTube channel called Audioreact Lab. And in particular, I would like to recreate the visuals from one of their videos. The link is in the description. They are pretty simple and are audio reactive, so they react to the music being played under the video. So the patch is pretty simple, so let's get started. Okay, so first of all, let's create our jit world object, as we know that we need it for every OpenGL related patch. So let's create the jit world. Let's give it a name, let's call it VJ, and then let's give it some attributes. For example, full scale anti-aliasing, default size of our window, position of our window, so if we are going to modify the word, the windows will always appear on the same position. Then let's put on the floating attribute, and let's set a background for our visuals, so let's make it black with full opacity. Let's take away the full screen menu bar, and then let's also set the FPS. In my case, I will put 120 because my screen has a refresh rate of 120 Hz, so I will also set the sync attribute to 1 just to be sure. So that's it for our jit world. Let's create a toggle to activate our jit world, and then I will also create a jit camera, so a GL camera, which is our point of view into our three-dimensional world. I will give it as an attribute the position, so 4 units back on the zeta axis. So we are now 4 units far from our scene. If we activate our world, nothing is displayed because the background is black. So the first thing we need is to create a grid-like shape. In order to do that, let's create a jit.gl grid shape object. And let's give it as a shape the plane shape. And then also the matrix output 1, because we will send this to a jit.gl mesh object. And then also the automatic 0, because we just need this object to output its matrix just once. So let's attach it to a bang to make it output its internal matrix. And then let's create a jit.gl mesh object. Let's give it a name. Let's call this target, because we are going to use the jit.gl multiple object. So this object needs to have a name in order to be targeted from the jit.gl multiple. Then let's give it a draw mode, which is line strip. This is the draw mode that best recreates the visuals from the aforementioned video. And then let's set also this one to automatic 0, because it's going to be drawn by the jit.gl multiple. Let's give this a scale of 0.8. Let's give it a blend enable, depth enable 0 in order to activate the blending, and then a blend mode of add. So sorry, I already have an object called target because I have the original patch opened in another screen. So let's call this actually just T. Okay, then we have to attach this object to that object. If we set this to automatic 1 and we bang it and we activate the render, oh sorry, the draw mode is actually incorrect. It should be line strip. So if we bang again our grid shape, it will output its internal matrix into the jit.gl mesh, and we will see our object that looks exactly like some kind of stripes. Okay, so now in order to have multiple versions of this object, we will have to use a jit.gl multiple. So let's create it, jit.gl multiple. The context name is VJ, and this has 3 GL params. So let's give it the argument of 3. Let's then write the target name, which is just T, And then let's write the GL params. So the first one is the position. The second is the rotate, x, y, and z attribute. And we have to apply to the GGL multiple a texture. So in order to do this, let's write what texture we actually want to apply. It's called text 0, still doesn't exist. Let's actually call it texture 0. Still doesn't exist, but we will create it. Then, in order to create multiple copies of our objects, we need to feed the GGL multiple with a position matrix. Let's do that. Let's create a JIT matrix with 3 planes, float 32, and then let's create, say, 16. Let's give it a dimension of 16, which means that we are going to have 16 repetitions, 16 copies of this object. So in order to create those coordinates, let's create a jit.gl object. Let's attach the matrix here, and let's attach the jit.gl here. Let's also create a bang button in order to bang the matrix. So inside the jit.gl, let's take a look. Let's delete these objects because we don't need them. We also don't need the in one actually, but let's leave it there. And let's create the signet normalized object. Then let's switch the x value. We actually don't need to do that because this object just has an x value, because this is just a one-dimensional matrix, so there is no y. But just to be clear, let's switch the x value. Then let's feed this x value as the x parameter of this of a three-dimensional vector. So this will be the x coordinate of a three-dimensional vector. The x, the y will be 0, and the z will be also 0, but the x will be in the range -1 to 1 according to the signet normalized coordinates. Then let's create another output, and this will be our rotation value, and let's rotate the y axis of 90 degrees. So let's see what happens if we connect this to the rotate value, and we have this interesting shape. Let me actually create a GGL handle to the multiple object so we can rotate it, and this is what we have got. So it's actually okay, but I would like that still our object, the original object is still drawn because we didn't set the automatic back to 0. So let's do this, and then let's bang again this grid shape. Okay, so now we have our 16 planes, but the thing is that I would like that they will be turned in a way that the stripes go toward that the stripes are vertical. So in order to do that, let's rotate again on the z-axis for 90 degrees. Oh, and this gives me this rotation. So this is actually not the correct rotation. Let's actually rotate it 90 degrees on the x. So it becomes like that. And then let's rotate it 90 degrees also on the z-axis. So now we have the correct rotation as I wanted it. Now, they are a bit too close. So in order to make them more wide, let's create a parameter. So let's call this let's call this parameter amplitude. Let's attach it to the jit.gl, and let's multiply the value from the signet normalized coordinates for the amp value. So let's create a parameter. Let's give it a default value of 1, and let's connect it to the multiplication object. So if we create a float point here and we change this value, when we bang, our planes will be more distant according to our multiplication value. If we attach this to the metro here, then we can just change this value and see our object gets farther or closer according to our multiplication value. Okay, so this is perfect for the moment. Now let's try to make this audio reactive then. So let's create an ADC object, so our microphone input, and let's attach this to a peak amp object. So this object will give us the peak amplitude for every frame, because we attached to the... Let's create a trigger just to be sure about the order of the operations. So we attach it to the to our render bank, so we are sure that this is the peak amplitude for every frame. Then let's attach it to... Let's take just the absolute value of that, because we don't want negative numbers. Then let's multiply this value for a big number in order to have a number that we can actually use, because the values out of the microphone are generally quite small. So let's see what we are getting out of that. So okay, values that range from 0 to around 7100. If we attach this here and attach the bank to this JIT matrix, then we already have an audio reactive, some audio reactive visuals. Now the problem with this reaction is that the shapes are going toward the center when there is no audio, because then the number is closer to 0. I actually would like that they go toward the center when the audio is louder. So in order to do that, let's subtract our amplitude value from another number. So let's see. If we subtract this from 40, for example, then when we speak, actually the planes go toward the center, and when there is silence, the planes are far as 40. The planes are as far as 40. So I don't want the number to go negative, so let's actually clip those values between 1 and 40. Because I don't want this number to be greater than 40 or less than 1. So let's see what we get. When I speak, the value totally approached 0. But I'm still not satisfied with this solution. I would like that they keep a certain distance. So let's actually keep this value, for example, to 4 and 40. So, or for example, 3. So this is the closer they can get. So we have to play a bit with the values in order to get a satisfying result. For example, let's try 70. This is already a bit better, because I would like that the planes stay still the less time as possible. So with this value for the amplitude of my voice, in this case, these values are okay. If we want to change the behavior, we can also change the number here in order to get a different amplitude value, and this will change how our visuals behave. We can also try, instead of using the pickup object, we can also try to use the snapshot object and see if it gets which kind of numbers do we get. So apparently we get smaller numbers. So let's reduce this range back to 30, for example. Okay, let's try, prova. Let's make it a bit bigger, because I would like that the planes completely go away when there is silence. So okay, maybe with a snapshot we get a better result. Let's now change the color of our planes using the texture attribute. So let's let's split this value here with a trigger object. So we send it first on the right and then on our multiplicator object. And on the right, let's connect it to another multiplicator object that will be the value of our color. So if I multiply this by 150, which kind of values do we get? Yeah, we get pretty good value. Let's clip also this one between 0 and 1, because this is otherwise it's anyway useless outside of this range. And let's attach this to a set all message for a matrix, followed by a bang. And then let's attach this message to a jit matrix of 4 planes, float 32, but just one single cell, because we just want to have a single color, in this case shades of gray from black to white, and this will be the content of our jit.gl texture. So let's give this a name, which must be the same we chose for the GL multiple, and then let's assign this texture to the single objects of our jit.gl multiple. So let's create another jit matrix, one single plane, because we have just one texture of type char and of dimensions 16, because this is the number of objects that we have. Then let's create a set all message, and we will set all the cell of this matrix to 0, which is the index of our texture inside this context. Then let's give it a bang. Let's bang this, and then we can see, let's actually detach this from here just to see if our texture works. And yeah, you can see now that our planes are getting brighter according to the sound, and dark when the sound is close to 0. So let's attach this back here, and as we said, we can also modify this value. So okay, this seems to work pretty well. Let's now create the vertical row, because there's also a vertical row that we didn't deal with since now. So let's actually duplicate. Let's move this a bit down. Let's create some load bangs for when we will reopen this patch in order to have all the settings automatically set. And let's copy this one. So let's try to make it fit inside this patch. Let's put it here, or let's put it somewhere like here. So what we have to change here, let's attach this also here. What we have to change here is the axis that we are going to change. In this case, we want to change the Y axis to have a vertical set of planes. And we also have to change the rotation, because in this case we just want to rotate the x value of 90, the x angle of 90 degrees. And then let's see what we get here. Exactly, we get what we want, but we have to attach also the amp value here. So yeah, now our Audioreactive patch is quite ready. Let's see how it behaves with some music. One modification that we can do is to get actually the difference between the average value of the sound and the current amplitude value. If the sound stays always at the same amplitude, we actually will have no movement on our. So actually, our planes will disappear, and this could be a bit more interesting. So in order to do that, let's create the average object. Let's give it a value of 500. I don't remember if these are samples or milliseconds. maximum average interval in samples. So, okay, these are samples. So let's give it, I don't know, 22,100 samples. So alpha second at my sample rate. Let's connect this here. And then let's use the snapshot. Also, let's use the snapshot and connect it also to this bang here. And then let's take the difference between those two numbers. So, yeah. And then we can attach this here and see if it gets a bit more interesting. Okay, so yeah, if you play a bit with those two numbers, actually the distance between the planes and the color, you can achieve some interesting effects, I think. If you want to give it a different color, then for example you could change those values here and get a different color for the visuals. Just remember that in this case this is our alpha value and this is our red value. So if we want, for example, a blue, we will do something like that. Alright, if we want a green, we will do something like this, and so on. So, okay guys, this was everything for this tutorial. I plan to do more of these remake of Audioreact lab visuals because I really like them and I think it can be interesting to try to recreate them inside Max. So, thank you for following, and I encourage you, as always, to visit my website that I will write on the description. And if you want to support me on Patreon, I will also write the link on the description. You can also check my Facebook page for news on my page that I continuously share, or articles, or whatever. So, thank you for following, and see you on the next tutorial. Ciao!